Hello everyone, and welcome to another video presentation, courtesy of the University of North Texas Physics Department with the assistance of the Physics Demo Room. My name is Corey Nick, and today we're going to be talking about heat and temperature with a little bit of emphasis on heat capacity. Now, with this concept, we have to first talk about what is heat. And heat is just the amount of energy transferred with respect to a change in temperature. So now the heat equation, as we see, is that Q is our definition of heat, usually defined as in joules, because it's just energy, just similar to what you maybe learned earlier with this semester of, let's say, potential energy or kinetic energy. That Q is equal to, I'm going to skip this C for a little bit, times the mass of an object times the change in temperature it experiences. This factor of C is called the specific heat of an object. All this does is a proportionality constant that describes how quickly energy or how much energy is going to be needed to take an object from one temperature to another. So a high specific heat means you have to have more energy. Low specific heat means less energy. So how do we see that in everyday life? So one example that we're going to have is that, or at least demonstrate that, is I'm going to have two water balloons. Actually, not two water balloons. I'm going to have two balloons. One I have with water, one I have with air. And what I'm going to do, hopefully, and hopefully not too loud for you, is light a candle. And what I'm going to do, have this candle just going, and we're going to see the differences between the two balloons. Now somebody might say, no matter what I do, when I put this balloon, the water balloon over that candle, it's going to pop. It's going to blow out that candle. Whereas, we're going to see if that's going to happen. So, what I'm going to do, I'm going to look away. That way I don't get blinded. Pop goes the weasel. And the candle blew up. Now, ooh, that's a lovely smell. Now I'm going to relight it. See if I can do it again. Now, hopefully, with this simple water balloon, I'm going to do the same thing. But from what I know is that in the previous balloon, it was just filled with air. So there was no other massed object inside there besides the air molecules to allow for heat to transfer and actually cause the temperature to change. But with the first balloon, with just that air, all of the contents of the balloon experienced all the heat or all the change in energy from the emission from that candle and went into there. Whereas now I have water, and water has relatively high specific heat compared to air. So now, if I was to do the same thing, nothing. Nothing at all. See, I even got a little burn spot where it's trying to, I can wipe it off. It's not popping. And that's all having to do with the specific heat capacity. Again, try to burn through it, no popping. So it's all because in order to get the water to the same temperature, in order to break or get it to pop because of thermal expansion, I need more heat, I need more energy to do it. So this source of this candle can't do it, whereas it could for just a plain air balloon. Well, thank you for watching this video presentation, and have a wonderful day.